Well, good afternoon, everyone, and welcome to the virtual learning course, The Impact of Site Layout on Construction Costs. My name is Sarah Snavely, and I will be moderating today's session. Just a few housekeeping items before we get started. This program will be provided both audio and web conference, and will last approximately 60 minutes, including Q&A. So if you have any questions at any point during today's presentation, you can enter them through the Q&A button at the bottom of your screen. As a reminder that this presentation is worth 1 AIA HSW credit, so certificates of completion will be sent out to all the attendees via email after the presentation. And now it is my pleasure to introduce today's speakers, Dan Ruby and Ryan Kiss. Dan, take it away.
Thank you very much, Sarah. Good afternoon, everybody. Thank you for dialing in with us this afternoon. I'm Dan Ruby. I'm here in the Virginia Beach office of Timmons. I've got about 18 years of land development experience here in the Hampton Roads area, primarily focused on public land development these days. So that's a little bit about me. I'll let Ryan introduce himself, and then we'll kick off into the meat of the presentation.
Hello, I'm Ryan Kiss. I also have about 20 years of land development experience. I started out in the construction industry, doing some surveying and some construction stakeout, as well as engineering. So kind of cross paths on all of those items, and that's my experience, my background. And so I'll go ahead and let Dan take it from here.
All right, I'm going to share my screen. So the title of today's presentation is The Impact of Site Layout on Construction Costs. Let's see if it will cooperate. Here we go. So a little bit outline of today's presentation. We'll do a little bit of a background on Timmons Group. Then we'll look at critical site constraints. We'll look at—
Hey, Dan.
Yes.
We're having a hard time hearing you. If there's any way, maybe you're facing a different direction towards the microphone a little bit more.
Okay, I'll try and speak up a little more. Is that better? Is that better?
A little bit.
Maybe. Let me try something else here. I apologize. Well, can you hear me now? Is that better? Can you hear me now? Is that better, Sarah? Ryan, can you hear me?
Yeah, Dan, go ahead and talk just a little bit more. That sounds a lot better.
Okay, sorry about that. So here's the outline of today's presentation. We'll do a little bit of background on who Timmons Group is. Then we'll get into the meat with taking a look at what some critical site constraints are. We'll look at where we can gather the information about those constraints. We'll look at how the design and the site layout can work with or against those constraints, and then put some dollars to that and counting the cost of what the impacts of those decisions are. And then we'll have some time for wrap up and Q&A. So Timmons Group, we are around 700 plus folks in our firm. Here's a map showing the number of offices that we have here in the Mid-Atlantic region. We're primarily focused on Mid-Atlantic region, though we do have some other offices around the country, starting to branch out there, but primarily focused on Mid-Atlantic. Ryan and I are both in the Virginia Beach office, and our corporate headquarters is a couple hours up the road in Richmond. Timmons is a full service civil engineering firm, so pretty much all the engineering disciplines that are part of civil we cover, whether that's survey, geotechnical, environmental, and of course the site land development that Ryan and I will be talking about today. So into the meat of the presentation here. So different projects might have different players involved early in the game. So there may be different folks from different backgrounds establishing an initial site layout. It could be, depending on the owner or developer, could get an architect involved early, or a land planner, or a civil engineer. But each of those different folks are coming from a different perspective. So the purpose of today's presentation is to share the civil engineer's perspective and to be able to hopefully walk away with a few tidbits of valuable information on things that could be taken into consideration early on to help the bottom line of the final product. So our learning objectives per AIA guidelines. First, we're going to look at which existing constraints need to be given consideration when we're putting together a layout. We're going to learn some opportunities of where we can find the resources to be able to make educated decisions about those constraints. We're going to take a look at making the site layout work, hopefully with the existing site conditions and not against, and then understanding how those decisions being made early on can really make a big difference, be a big benefit to the final site construction costs. So we'll start with critical site constraints. So here's an example of a project, 431 acres, which of course sounds like a lot of land. And this is a piece of property that was being considered for a high school and a middle school. And there are the kind of self-evident components that you start looking at first off to be able to pare down what your net usable area is. So you got the things like setbacks, easements, buffers, wetlands, overlays, flood zones, conservation areas, all those kind of things that are fairly straightforward and can help start identifying what areas of a site are useful or not. And of course, we find that 431 acres, especially when it's getting chopped up with streams and things, can get pared down pretty quickly. But that being sort of a first blush look at a site, we want to actually take it to the next level and look at some additional site constraints. I will say the picture here is not of a Timmins project. This is pulled off the internet, but that's the exact kind of thing that we want to avoid. So the three that we wanted to focus on today are site topography, stormwater outfall points, and utility connections. So clearly here in this picture, site topography was not taken into consideration when they set that house up on the top of the hill there. That is what we're trying to avoid so that kids can play basketball in the driveway, because there's no playing basketball in that driveway. So here's an example that we'll take a look at, a site layout with some contours on it. So we start just being able to identify broadly where the highs and lows are, and we see some contours identifying that information. And as we process that, we really identify where our high areas are on our site, where our low area is on our site, and want to be cognizant of that when we start looking at how we're going to use the site. So if you have a decent amount of topography, like this example does, if you select your building in a site that's high, you a lot of times end up having to have an excessive cut to be able to level out the site. So you're cutting down the high to kind of average things out. And then conversely, if you were to want to site your building in the low area of the site, you're going to end up with excessive fills. Ideally, we're trying to balance the site, but taking that into consideration when we're siting the building will help ultimately on our earthwork costs. Then the next area of consideration when we're looking at the topography is what are the drainage patterns? So drainage runs perpendicular to contours. And so we can kind of get an idea, and the arrows set up here show generally what we would anticipate drainage patterns being. So if we're going to be cognizant of, if we're going to block a drainage pattern, we're going to have to pipe around it, which there's of course a cost associated with that. And not that we can't usually work around it, it's just another consideration to take into account to try and keep our site costs reasonable up front, if at all possible. Now, we know that there's a million different variables involved in laying out a site and different priorities based on what the owner needs and wants and what the rest of the site needs to do. So not, of course, all these things are avoidable, but we're just, again, being cognizant of the fact that if we can avoid blocking drainage patterns, then we can save ourselves the costs associated with going around them. The next point that we wanted to look at was the stormwater connections. And so this site happens to be, this example that we're looking at, happens to be one that is part of a master planned development. So there wasn't a BMP shown on that site layout, which is good for the sake of we don't have to worry about setting aside real estate for that. But what we do end up with is a very specific point where the stormwater pipe has been stubbed to our site, where we need to send all our drainage, presumably to go to a regional BMP. But so that sets a very defined point and a depth of where we need to convey our stormwater to. So depending on where that is can drive a lot of decisions on how to be as efficient as possible with our stormwater system. Next, we want to take a look at the utility connection. So the two major ones that we consider are the water line and the sanitary sewer. So on this example, the water line is coming across here on the north side of the site, and the sanitary sewer, similarly to the stormwater, as a master planned development, again, has a particular location where that pipe has been stubbed to serve our site. So not only a horizontal location, but a vertical location with the invert on that pipe being a very important piece of information for the consideration of our site layout. So the water is a little more forgiving, of course, because that's a pressurized system. So it can go up and down with hills. It can go up and down around conflicts with other pipes or other infrastructure. So that's a little more forgiving. Sanitary sewer, less forgiving, given that it's a gravity system. So we work from that invert and we work our way up to the building. The problems that we can get into if either that invert is very shallow or if our building is very far away is by the time you get, you run that length of gravity sanitary pipe a certain distance, it can rise and cause problems if the site doesn't rise along with it. So again, just keeping in mind that that depth is important, because otherwise that could drive your finished floor elevation of the building. You might have to raise the building finished floor, which would involve, of course, some additional earthwork costs. Or you look at something like the potential for a lift station, which not only has costs associated with the capital cost of it up front, but also the operations and maintenance costs of it forever and ever, for electricity, for replacing pumps and those sort of things. So again, we're trying to take into account things, work with them. So the invert of the sanitary sewer and the relationship of the building to that location is very important. The next step, now that we've identified the types of information that we want to gather, where can we find that? And how can we inform ourselves to be able to know what we've got going on with our site? And the first primary resource that's available broadly is information on municipal websites, online GIS, and the data sets that you can download from various municipalities, most of which are just available at your fingertips at your desktop. So here in Hampton Roads, we've got many municipalities. These are just a few examples of some of the different websites that are available with a lot of different information. And you may notice that some municipalities have more than one, Norfolk Air and Interactive Norfolk. There's a lot of times they split it up based on really what the gist of that information is that they're trying to convey. So a lot of times there'll be one website that's really geared more towards the parcel and tax assessment type information, and then there'll be a different database with more of the infrastructure side of things, which is primarily what we're looking at today. But generally, to find this information, it is usually pretty easy to find. You Google the locality and GIS, and you'll get these, and it's generally pretty easy to come around to. So taking a look here at an example of online GIS, this is just available in your web browser. And this is an example from the City of Virginia Beach. City of Virginia Beach has a very robust online GIS database. And so you see here, we've got road networks, we've got building locations, we've got contours. So again, going back to the first things that we discussed here, we're able to take a look at this and see, get a general idea of where's high ground, where's low ground, how are the contours laid out, to be able to get an idea on which direction the drainage patterns are going to be, where it's going to be high, where it's going to be low. Then toggling around the different information, you can toggle off the topo, toggle on. This is the stormwater system. So again, a good, robust system in the City of Virginia Beach. So you can see here where there's manholes and inlets connected by pipes. They even give you pipe sizes. And a lot of times, if you were to click on any of these structures, there very well may be information about rim and invert information, so that you can get an idea on how deep it is. That information is, GIS level accuracy, not survey level accuracy. So this doesn't replace the topographic survey, but it gives you a very good starting point to know what you're getting into and what kind of opportunities and constraints you've got for the site. This is about the extent of what you can see online for water. So water systems are considered critical infrastructure, and generally for protection to some degree from vandalism or terrorism. Most times the water lines themselves won't be public information on the online GIS, but here it does show you where hydrants are and water meters. So at least you've got an idea on if there's some water, if there's fire hydrants on this line, you know you've got a half decent sized line. But generally then to get the missing information here on where is the water line generally and what size is it, that might involve a call down to the city to somebody in public utilities or a trip down to the city. City of Virginia Beach has a couple of kiosks available to the public where you just go into the building and you can pull up this information, and there's additional information there than even what's on the website with respect to water mains. The second component of the online information is data sets. So that being information that's either GIS or CAD that is available to download, and then you can manipulate that and play with that in various softwares. But to download the data set. So this is an example from the city of Chesapeake. And this is just a snapshot of a piece of all the different information that's available. There's numerous others, but what I wanted to start with was parcels. So to be able to get a CAD file with some parcel information to be able to start, for example, laying out a site. So if this was the site that you're looking at, you've got a CAD file. Again, this is GIS level accuracy, not boundary survey accuracy or topographic survey accuracy. But again, it gets you in the ballpark, it gets you pretty close and gives you an idea of where your property lines are, what some of those constraints are. Then from there, you can start adding on layers on top of layers of all the other data sets that you can download. So this that just toggled on is of course the topographic information, which would also generally have Z values associated with it. So you'd be able to see again what the general elevations are, what the general drainage patterns and those sorts of things are. So again, a good jump start on having some information to be able to intelligently lay out a site ahead of having to go with full topographic survey and the time and costs associated with that. So now that we've identified the constraints and found some websites and things to be able to populate that data, I'm going to turn it over to Ryan, who's going to continue on with how we work with or against those constraints.
Okay, very good. So as Dan mentioned in the handoff, we've talked about identifying the constraints. We've talked about what are the things we would look for.
Can't hear you, Ryan. You're muted.
All right, here we go. Good?
Still can't hear you.
People in the chat are saying that they can hear me. So maybe Dan, it's just you.
It's just me. Sorry.
Okay, I'm gonna keep rolling.
I can hear you now. Sorry.
Can you hear me now?
Yes.
All right. Cool. All right. So thanks everybody in the chat for jumping in there and helping out with that. Appreciate it. So we've talked about the identification of the constraints. Now we're going to talk about the decision-making process, how we would use the information that we've gathered to look at a site, to make decisions, and how the decisions we make can ultimately impact the site costs. Either it's going to add to the site costs or it's going to help bring them down. So regardless of who it is that's making the decisions, whoever's laying out the site, and we all still have basically the same building blocks or components to work with. We have a building that we have to fit on the site. We've got associated parking to that building that we have to fit on the site. Oftentimes there are open space requirements that we have to deal with. And then we have our stormwater management facilities, or our BMPs. Most of the time they're above ground. More and more often, because of the value of land, they're starting to go underground, but we still need to take that into consideration as well. So we've got the same parts and pieces that we're dealing with, but we can organize or put these together in a lot of different ways and come up with different solutions on our site. And how we do that definitely does have an impact on the ultimate site costs. And that's what we want to make you aware of, or anybody who's working on site layout, how these decisions are impactful to us. We're going to go through these in the same order that Dan mentioned the constraints to begin with. The first one that we want to talk about is site topography. And what I want to talk about first of all is the decisions that we could make that maybe would cause us to work what we would say against the site constraints, not working with the natural lay of the land or what the topography gives us, but kind of bucking grade and really driving up our site costs. So if we look at this, what we have in the lower section here is a profile or a section cut across the existing ground. This dashed line would represent the topography of the existing ground. We can see, as Dan mentioned earlier, we placed the building in a fill condition, I'm sorry, excuse me, in a low point on the site, which is causing us to have to fill in this low area because we want to get the building pad up so that water drains away from the building. As we do that, we start to lay out our parking lot. And that parking lot, again, we want it to drain away from the building, and we want to start to pick up the drainage off the parking lot in inlets and a pipe system that needs to run by gravity down to our stormwater management facility. Well, as you can see, the stormwater management facility has been placed over here in the high area of the site. And by the time we pipe this system down, we end up having to set our stormwater management facility so low that this is requiring almost 20 foot of cut into this hillside to get the system to work. So can we make a site work like this? Yes, absolutely we can. We can lay it out. This could function. And a lot of times this is the way it would have to be. Maybe the building needs to be placed here for visibility from the road or for other reasons. And this is all that we're left with, and we've got to make it work. But we do need to realize that in doing so, we are generating additional costs. The money that it's going to take to fill this section of the site, the depth of the storm sewer, the money that it's going to take to cut the material out of this hillside to be able to dig the stormwater management facility, all of these are driving up construction costs. So with that being the case, if we're making this decision, one of the things we want to do is be coordinating as a team, talking about it, understanding that site costs are going up, and being certain to communicate that to our client or the project owner so that it doesn't come as a surprise to them. The last thing that we want is at the end of a project to have them price it or get a contractor to price it and then be shocked at what's happened to the site cost. So if we see this, if we know that's going to be the case, we want to do a good job as a team of communication of those things. So this would be an example of a site layout that really does work against the site constraints, even though the site can work itself. Well, what would this look like if we did it the other way? What if we worked with the topography of the site and flipped this completely? Well, this is what it would look like on the other side. Here we've got the building pad sitting at a higher area of the site. We've got maybe a little bit of cut that we're going to do out of the hillside to make things more realistic or reasonable. Now we've got a parking lot that again follows the grade of the existing land. So there's not going to be a lot of earthwork there. The storm system's kept relatively shallow. We're still collecting our drainage. We're running off towards the stormwater management facility, but now because we've dropped the stormwater management facility in a lower section or a lower portion of the site, we have, maybe 5 to 7 foot of excavation here rather than the 30 foot that we saw on the other slide. It's much more reasonable, much more realistic. So we've got a little cut here, we've got a little cut there. And at the end of the day, this site, the construction costs of this site are going to be much, much less than in the previous layout. Now I'm going to go back a slide. One of the things Dan mentioned as he was discussing this, oftentimes we look at the cut and the fill and we say, well, maybe we want to balance those out. So maybe this isn't so bad because we're taking the cut from this area, we're using it to fill up this portion of the site. Well, we need to be aware of the fact that that's not always possible. It all depends on the nature of the soils that we're cutting and what we need in the fill conditions. So the geotechnical report would be very important early in the game. If we go into this and just blindly think that cut can balance fill, we may be surprised during construction to find out that we've made this decision, but we've got some really terrible material in this hillside that can't be utilized. And so all of this needs to be hauled off. So it's a dangerous assumption to make right up off the bat that that's something that's going to happen. You want to have a little bit of backing information, especially if you're going to have excessive amounts of cut and fill. And even if you are balancing a site and balancing between them, this dirt still needs to be excavated and still needs to be moved. So even though you may not be importing or exporting a lot of dirt from the site, you're still moving a lot of dirt around on the site, and there's still a price tag and a cost associated with that from the contractor as well. So just keep that in mind, that doesn't just make your dirt problem go away if you say that you're going to balance your cut and fill. There you still are driving construction costs in doing so. So that's site topography. It's definitely a big one. It's one of the biggest ones for us to consider. The next constraint that he had mentioned and that we want to talk about is that stormwater outfall point. Once again, you have a point or maybe multiple points along your site where stormwater needs to go to and is going to drain to. By just a simple identification of where that is up front, it may start to influence how you place the components of your site. We received this layout from an architect, and again, if this building faces the road, it's kind of a longer, irregular shaped building, and it's doing a couple things to us. One, with the topography, that natural drainage pattern, if you recall, runs down the middle of the site and wants to come on down through these contours and hit this point. So we've created kind of a dam in our site by placing the building out here in the middle. We can fill this in. We can start to deal with that. It's doable. Again, we're raising construction costs by bringing in dirt. But another thing that's happened is we now have to deal with all the drainage from upstream that was coming through here before. How are we going to wrap it around the building? Now, because we have our tie-in point all the way over here, we now have to wrap storm sewer all the way around. We've got multiple bends and turns that we need to make with different junctions, whether it be manholes to make these turns and the angles. And we've got a lot of pipe that we're going to install. So even though this layout can work, this layout is going to generate a higher construction cost than one that maybe left this area open or available by placing parking lot or other things here where we could pipe that water directly underneath that parking lot, get it through this point, straight line, straight shot. The construction cost in doing that would be much less. So just something that we want to think about, something that we want to consider, and this is a pretty good example. A second example of where that storm sewer outfall point kind of came back and became a problem on a real site in a real scenario. This was another project that we inherited a site layout from another firm, and there were a lot of good things about this layout, some nice positives. They had placed the stormwater management facilities in the back quadrants of the site. One of the ideas was that this property is surrounded by existing residential homes. So they felt like rather than putting buildings back along the back property lines, much nicer for those people that already live there to be looking out over some nice ponds, some stormwater management facilities instead. So that sounded great, seemed great, except when you start to factor in that we needed to tie the storm sewer systems into an existing pipe right at this location, which ultimately ran under the road and discharged into a stream on the other side. So now, all of a sudden, this stormwater management facility over here that looks so great on paper started to become a problem because we had to install this really long run of outfall pipe to get the water out of the pond, let alone getting water back into the pond, but getting it out of the pond to that point. There was a huge cost associated with the installation of that system. Now, I'm sure already wheels are starting to spin and thinking about, well, what does that mean? how much, what's the order of magnitude of the cost that we're talking about on these items. As we move along, I'm going to get into those. We will talk about the actual construction costs of some of those things, so you start to get an idea. So if you're starting to question that, we'll come back around to that. So now, again, we started with this layout, but if we look at a secondary option to this site, you can see buildings have changed a little bit. We collaborated with the architect on this to kind of rethink and reconceptualize the site to try to find a better option. They did some work with the buildings themselves, consolidated some units. We worked the parking layout to try to get the required number of parking spaces. We still met the open space requirements. But what we were able to do that was a huge savings was to move that stormwater management facility from this back corner that was so far away from our connection point. We were able to slide that, combine it into one facility over in this corner. And now you can see we have a much shorter run of pipe to get that to work. It helped us in design, it helped in construction costs. So for a lot of reasons, this layout ended up being a much more favorable scenario than the one that was originally conceptualized on paper once we had that point identified and we started working with that constraint. Now we want to talk about sanitary sewer and the connection point there as well. It impacts us in a very similar way to that stormwater connection point. We have a set location that we have to tie into. We have to bring our sanitary sewer to. That location is going to have both a fixed horizontal location, but also that fixed depth. Now, here in Hampton Roads, Virginia Beach area, one of the things we run into a lot is that all of the utilities that we deal with, or most of the utilities that we deal with, are really, really shallow. So oftentimes we'll find ourselves maybe with 4 or 5 foot of depth at that connection point. So what does that mean to us? How does that impact cost, just the depth of an existing sanitary manhole? Well, we've got to tie into that point. We've got to tie into that invert elevation. But then by code, we also have a minimum slope that we need to run this sewer at so the gravity works and is acceptable. We're usually working with a 0.4% slope as an absolute minimum. So now all of a sudden the length of this run and the slope of that pipe start to impact for us what the ultimate tie-in point or invert is at the building. We can't do anything about our elevation here, and we can't do anything about this slope, so we're locked in at this point. And what that starts to do for us is it begins to drive the finished floor elevation. It begins to set what that needs to be at. So many times we'll reach out to an architect very early in the project, and oftentimes we're finding it's even before MEP has been signed up or has started doing their work. We're asking, hey, do you know where the sanitary sewer exits the building? And do we know what the minimum depth of sewer connection below finished floor is? And we're asking that, and we're asking it early in the game because that really is determining finished floor elevations for us in many cases. If we were to find out later that that sanitary sewer connection point was on the back side of the building over here, we've got that much farther that we need to run the pipe, and that fixed invert starts to get higher and higher, which means the finished floor now needs to get higher and higher as well. So with sanitary sewer, knowing that connection point and location is important, probably not so much in just the material of the sewer line. There's some expense there, but really the bigger part of it is how that can impact that finished floor elevation and the fact that it may cause us to have to fill a site up way more than we want to try to make things work. Whereas if this building were placed closer to the sewer connection point, you've got a shorter run, finished floor gets lower, and now your site costs begin to come down. And another item that can come back and get us as well is that if we cannot get gravity to work, if we just can't make this work, then all of a sudden we're switching over and we're starting to talk about an on-site pump station and the cost that goes with that. This scenario is one that we ran into that exact situation and exact issue. Our sanitary sewer connection point was at the far reaches, actually off-site on a road behind the project. There just wasn't much available to tie into. And once again, it was a very shallow connection point that we had to work with. And yet we had to get sanitary sewer all the way back from the buildings on the far point of the site, run it back through the site, and then because this stormwater management facility, which gave us problems in the outfall situation, also gave us problems with sanitary sewer as well, being located there. It meant that we couldn't shortcut across here, cut down on length of sewer. We ended up having to wrap all the way around that pond. And what we found was that by the time we did that, we just couldn't tie in to the invert that was set here. The only way to have been able to do that would have been to raise this quadrant of the site up and elevate it 4 or 5 feet more than what we really wanted to. So in this case, the site layout, dropping a pond right here in the conceptual stages, made it so that designing gravity sewer became impossible, and we had to go to a private pump station as the option for getting sewer from the buildings to that tie-in point and to that connection. And so there was a huge cost associated with that as well. Again, all impacted by the way the site was laid out and the choices that were made on where to put the ponds. So if we have the ability to do it, and as always, we're not saying that these are the ultimate answers to how you configure a site, but if we can, best case scenario, these would be the things we would look for to work with the site constraint of that sanitary sewer point. We want to place the buildings as close as we can to our ultimate connection, because that gives us the most flexibility in setting a finished floor elevation. We like for the building sewer to be able to exit on the side of the building as close as possible to that connection point. For the same reason, gives us flexibility of setting the best finished floor elevation that we can to keep the cost down. And then if possible, we don't want to place buildings or stormwater management facilities in locations that are really going to cut off access and make you really have to go a long way out of your way with your sewer runs to try to wrap around them, because oftentimes by adding that extra length, it makes connecting in either not feasible or it causes us to have to elevate finished floors on the upstream side of things way more than we would want to. So these would be the items that we would want if we were looking to work with that constraint. So now let's talk dollars. Let's get into probably the more interesting part of this. Each one of these constraints comes with a cost. How much does each of these items cost, and what were the impacts in the examples that we've been talking about? We're going to go through in the same order again. Let's start out with a big one, and that is our earthwork costs. As you know, site or construction costs in general fluctuate depending on the project, depending on the time, depending on who your contractor is. So these are just some general rule of thumb numbers that we use in estimating site costs. They go up and down. When it comes to dirt, bringing dirt into a site, a lot of times it's dependent on how close is the borrow area where you're bringing site or dirt from, and where are you disposing of your dirt? How far away is that? Because that impacts the haul costs for the trucking. So these numbers can fluctuate, but a pretty good idea. You get $15 to $25 a cubic yard to bring in select fill to your site. If you've got unsuitable materials that you've cut and you can't lose it or waste it anywhere else on the site, which is becoming more and more difficult as we pack our sites full of buildings and parking lots. It's just not an area to spread bad dirt. We don't have a lot of open areas to work with oftentimes, so it just has to go off site. It's pretty similar, a little bit lower to haul it off than it is to bring it in, but those are your costs. So let's start adding some of these numbers up. How much dirt would it take to raise a 5-acre site up by just 2 feet? If we take our 5 acres and convert that over into square footage and then raise the site by 2 foot, that gives us our cubic footage. And then convert that over to cubic yards. We've got 16,000 cubic yards of material that it's going to take to raise that 5-acre site up just by a couple of feet. Sometimes hard to wrap our head around what 16,000 cubic yards of material looks like. So what is that? Let's try to picture it a little bit better. A standard dump truck load that's packed full carries about 10 cubic yards. So if you're talking about having to raise your site up by this much, you're going to have 16,000 cubic yards of dirt. You're talking about 1,600 dump truck loads coming into your site. So now all of a sudden it starts to click as to, why is this such a big deal? Why is there so much expense there? And now if we start applying dollars to that, what does it cost? 16,000 cubic yards, even if we take sort of the middle range of import, you're talking $320,000 to get that site raised up. If that's what it takes and that's what it has to be, that's what it has to be. But what we're getting at is sometimes we can make decisions where this number can be brought down substantially. And now that money either goes back to the developers' pockets, maybe it goes into items on the site that are a lot more fun to spend money on. I mean, honestly, who wants to put the money into dirt? This money could be spent on better finishes, better signage, other things on the site that just make it more aesthetically pleasing rather than just dirt. So why waste the money there if we don't have to? If we can work with a constraint and bring it down, we want to do that. So what does the client see when they see 16,000 cubic yards of cutter fill come in from their contractor? Well, they're basically seeing this. It's just dump truck loads of money just either being brought in or hauled off the site and just wasted on their project. So we always want to pay attention to that topography, pay attention to our earthwork numbers, and try to make decisions early on that are going to save us money and construction costs. Storm sewer pipe. Let's run through some generalized numbers on this. Again, these fluctuate as well. But as this is a concrete pipe, reinforced concrete pipe, as the sizes go up, as you would expect, the price per linear foot is going to increase. Then you've got to take into consideration that every time you make a turn or a bend, you've got to drop a manhole or a structure. Each one of those may cost $5,000. The deeper they get, the more the cost runs. And if you have these really large pipes, you start getting into 42s and up, you maybe are having to install junction boxes instead of manholes, much larger concrete boxes that'll accept that size pipe. Now you're talking about $8,500 per turn that you have to make. So these can all add up in a hurry. Now let's look at that scenario of the site that had the really long outfall stretch versus the much shorter version and see what the ultimate cost would have been. So with this layout and with this site layout, with the pond being in the back corner and our connection point being all the way over here, we had to run what would have been about 1,750 linear feet to get from here to the corner over here. Based on the design of the facilities, and this is something we wouldn't know up front until we start doing some design work, the outfall pipe itself needed to be very, very large. It was going to be a 42-inch pipe running through the site. So the pipe system alone was going to run about $218,000. And then again, for each one of these turns, because we have the really large junction boxes to accept a 42-inch pipe, we've got 12 of those to make all of these turns and these breaks. That's about another 100,000. So end of the day, we were talking about just this outfall system from the one pond running us $320,000. But now on the flip side, when we look at the other layout and the other outfall system, this is what we came up with. Now your outfall system, although it still had to be a 42-inch pipe based on the design and running the stormwater models, we now only had 225 linear feet of storm pipe. We only had one turn, and then we were straight to our connection point. So one junction box here at $8,500, and the cost of the outfall system now was $36,000 instead of $320,000. So really big difference for a site that basically works and functions the same way. Same number of units, same number of parking spaces. We've consolidated the pond, so really there'd be cost savings there that the contractor's not excavating and working in two different areas, but just the piping system alone, we had about a $300,000 savings by just switching up how the site was laid out. So we can really get a feel for the impact that this can have on us. And how about the sanitary sewer systems? You got some general costs laid out here in the PowerPoint as well. PVC pipe versus ductile iron pipe. Costs go up as the pipe sizes go up. Manholes maybe not quite as expensive, but as they get deeper, they're going to go up as well. Big ticket item down here, that on-site pump station. If you can't get the site to work using gravity and you have to install that system, pretty good price tag that goes with that. So let's look at a couple examples again here. We had this situation where the building was placed a long way from our connection point. To be able to install the system that was necessary, and sanitary sewer systems costs not the big item, To get that installed was going to be about $21,000. So even if you'd moved it closer, you know, what do you maybe save $10,000? Maybe not that big of a deal. But where the real cost addition came in was the finished floor. If you remember, being so far away drove the invert, which drove the finished floor up. We had a finished floor of 11.5 with an existing ground at elevation 9, and you're filling for your building, but you're also starting to fill out into some of your parking lot until you can start making up grade. So I just took an estimate of that area, general area that I felt like we would have to fill. If we just filled that up 2 feet at $20 a yard, the fill cost for raising that building up to the elevation it needed to be at was going to be about $140,000. So again, it's setting the finished floor that becomes more critical than it is just the materials for the installation of the sewer runs. And the dirt costs are such a big deal. So if we can do things that will help us on that end, all we're doing is helping our bottom line number for our project. And then if we go back to this scenario, again, this one, if you remember, we weren't able to get gravity to work based on this initial layout. It caused us to have to install that pump station that had about $150,000 price tag to it. It had design fees that went with it. And then also on top of that, Dan mentioned this before, it's not just the owner being on the hook for the initial cost of the pump station, but for the life of that pump station. He's going to have to do O&M. He's got to operate, maintain it. Maybe somewhere down the line, there's replacement of components. So really that's a cost that just continues to add and add and add over time. So we never want to use that as an easy out and just say, well, we can just put a pump station in to make things work. If at all possible, we want to avoid that. We want it to be a gravity system. And not only do we want that, but municipalities prefer that as well. On this project, when we thought we were going with a pump station, the city of Virginia Beach made us prove every way possible that there was absolutely no other option to make this site work by gravity, and that pump station was going to be absolutely necessary. It was not something that they were just going to readily accept and be okay with. So on that end too, it created more hoops to jump through and more difficulties for us to get it approved. So then with this pond being out of the way, with that secondary layout, we were able to make the connection, make gravity work. We dropped that $150,000 price tag. We were able to drop $300,000 in dirt. And just by switching the layout around, the client saw a savings of close to $500,000 on this project, just from those components alone. So it really is a big deal. That's why we thought this presentation would be worthwhile. It'd be good for, for others who are doing site layout to realize that the decisions we make early on really can have a bottom line impact on the site costs of a project. So just to summarize the items that we talked about, what are the constraints that we want to identify and look at early on? Well, we want to look at site topography. We want to look at that stormwater outfall point. We want to try to figure out where we're tying in with sanitary sewer. And always, we want to let everyone that we work with know, maybe these are things that you're not used to looking at, not sure how to pull it all together. If you have questions, they don't take long for us to look at and do a quick analysis. We'd be happy to jump in as a part of the team and give the project a once over, look at a property boundary, pull these pieces of information in and help maybe give some guidance or some thoughts on them. So if at any point, you need help with this and want to consider these at the next level, we'd be happy to jump in and be involved. So if it's site topography, don't place those buildings at the highs or low points of the site if possible. Definitely try not to put the stormwater management facilities in the high areas. This is a nice example of, you can see this sits down on a lower portion of the site. It's not sitting up here on the hillside. So water is naturally able to get down to that point. We want to identify that stormwater outfall point. Here obviously would have been down in this area. So if the stormwater management facility again had been put way back at the back corner, you've got that entire length of pipe just to get it to dump where you need it to dump. And then the sanitary sewer connection point as well. Be aware of that. If we can, put the buildings close to them, avoid putting things in between in the path, and just always generally be thinking about these things. They're not the ultimate decision makers, but they are factors that we should all be taking into account as we do site layout. So at this point, we can open it up. If there are any questions that anybody has, I'd be happy to field those and give any clarifications or answers to any curiosities that you have.
While we are waiting for some questions to roll in here, I just want to remind everybody that you will receive a certificate of completion for this course via email from us post presentation. We also have another presentation coming down the pipeline on June 18th. It is what's coming down the pipe, a discussion on sanitary sewer. So if you haven't registered for that, you can go to our website at www.timmins.com to register for that next one. But I don't see any questions coming in. I think you guys must have done a great job explaining everything.
Great.
Got some here. Can you go over how you figured out the number of junction boxes for the stormwater?
Yeah, so the junction boxes would just simply be counting the number of places where we had to turn. So if we go back to this layout, it would be every point that we had a turning point through the system. And there are some very subtle bends through here that we had to hit because we had to keep it out of the city right of way and also try to keep it away from the building. So there's probably more through this stretch than what you're seeing. But pretty much anytime there's a change of direction in the pipe, you can't bend concrete pipe. So you've got to put a structure in there to be able to make that turn, even if it's a very subtle turn.
The example is the combing in the SWM facilities into one location. How much of the cost savings was offset by the additional on-site stormwater pipe?
Well, I think when it comes to this scenario, you're getting cost savings on both sides. It's not really an offset, or maybe I'm not quite understanding the question. And none of the numbers here factor in the consolidation of the pond. These are all just the outfall system themselves. So, really you would have had some additional savings added onto this by consolidating the pond. And I didn't run those numbers. A lot of that would be contractor, probably labor costs more than just excavation costs. Excavation was probably about the same. So I'm not sure if I quite answered that.
It might have also, the question might have been referring to the idea that you've got to get the water to the pond in the first place, but the benefit to this layout is that you're not running water east to run it back west. So the whole time the water's all headed in the right direction the first time, and that you're not having to run duplicate pipes.
Got you. And as well, that's a good point. I didn't think about that. But yes, you would, by not having the pond over here in this corner, it's true some of these areas have to be piped farther to get to this other pond. But the water, or the pipe carrying the water going into the pond was also much smaller. We didn't have the 42-inch pipes. It would have been, maybe 24s or 30s with smaller manholes. So the size of pipe would have mattered too. So there maybe was a little bit of increase in storm sewer costs going into the pond, but nothing nearly what we would have been spending on the outfall pipe. It's a good question.
How much is predetermined at the rezoning process on the design and later resulting in an increased cost to the developer once engineering of the site is done?
That's a great point, because this was a very real world scenario of that. We inherited this layout after a rezoning was already done in place. And oftentimes the municipalities expect the site to stay in substantial conformance with what the layout that they saw and approved at the rezoning was. So the client had to go back and really ask a favor of the city to consider this change in layout to be in substantial conformance. But that really can, and that's why we're probably trying to push this idea of thinking it through and probably involving more members of the team early on in the project, not waiting until after rezoning to bring a civil in to give you an idea of what's going on, because you can get locked into some of these decisions. And then despite the fact that later, and that's where we were here, we realized right away this was not a great thing, but we felt like we were handcuffed to it because it had gone through the rezoning process and there was very little we could do to make the big change that we wanted to make. So it is very important to think about these things early on so that you don't create a situation that we can't undo after the rezoning is in place.
Okay, I think that is all the questions that we have in right now. I think somebody just messaged in and hit the nail right on the head as to major takeaway is to get Timmins involved very early, which correct.
I like that. Yeah, very good.
Get us involved early on the project. So thank you all for your wealth of knowledge here, and thanks everyone for attending today. We greatly appreciate it. Again, if you haven't registered for the next one on June 18th, visit our website, and we hope you have a wonderful rest of the week. Bye, everyone.
Bye. Thanks, everybody.
Bye.